Hey everyone, I'm going to talk about section 3 from chapter 15, volume of spheres. Hopefully you watched that YouTube video on how they derived this formula and it made a little bit of sense. I know it's a pretty complicated one to figure out, but the formula is volume equals 4/3 pi r cubed. Okay, that's where you need to be really careful now because the radius of the sphere is cubed. Okay, and the radius is just the very center point going out. Okay, and obviously the diameter would go all the way across. Alrighty, so we are going to work through a couple of these problems together. You could use a regular calculator, scientific calculator, you know, whether it looks like this one here or, you know, on your phone. Yep, those were my kids, right? This kind here, that's to the third power x. You even have cube roots, square roots. This is to any root. This is to any exponent. Okay, so the calculators get pretty fancy. So we're going to try number 1 here. Volume equals 4/3 pi r cubed. All right. The volume equals 4/3 pi. The radius here is 4, so this is times 4 cubed. Okay, so volume equals 4/3. 4 cubed is 64, so times 64 times pi. Remember, we leave everything in terms of pi until the very end, because sometimes we work with it in terms of pi and we just keep it that way, okay? 4 times 64 is 256, so this is 256 over 3 times pi, and that's what it looks like in terms of pi. And I know that that's pretty funky, but this is right when you would start to calculate from this point. Okay, you would literally in your calculator do 256, divide it by 3 times the pi button. Remember, we're using the pi button now. Okay, so your volume is about equal to 268.1 centimeters cubed. The directions say to the nearest tenth, so we leave it that way. Don't get thrown off by things looking funky like this. It's okay. If you start cross-canceling or doing anything or multiplying and dividing by 3, you end up with all these, you know, repeating decimals and things. So it's easier, just leave it in terms of pi and then calculate at the very end. Okay, so that's how you find the volume of a sphere. Let's look at example 2. Make sure you can see it. This is finding the radius. So the volume is given to you right here already. Notice the volume was given to you in terms of pi, just like it was given in terms of pi here. The only big difference between these two, you guys, is this is 288 pi. This is 256 over 3 because it doesn't simplify to a nice, simple, you know, whole number like that, okay? So you would just leave it. So again, it's volume equals 4/3 pi r cubed. Substitute all the values you have in, right? Here's my volume, 288 pi, and that's equal to 4/3 pi r cubed. Okay, I want to show you something, that this right here, okay, is really, it's the same. You can write it like this too, you guys. This is just 4 pi over 3. Okay, because you know if you multiply it, the denominator here is 1, the denominator here is 1. So I'm going to kind of rewrite it like that so you see that 288 pi equals 4 pi over 3 r cubed. And now you can see if this is what we're solving for our radius and we have a fractional coefficient to the radius, we're going to multiply both sides by the reciprocal. Okay, so we know that this is over 1. Right? The reciprocal of 4 pi over 3 is 3 over 4 pi. So I'm going to multiply this side by 3 over 4 pi. I'm going to multiply this side by 3 over 4 pi. I'm just putting it out here. I'm not even trying to squeeze it in right there because it's a little bit too much. We know the pi's cross cancel. This 4 pi, this 4 pi, this 3, and this 3 all cross cancel. So you're left with your radius cubed here. Okay, which is what our first step in solving for something. And then I just go 3 times 288, divide it by 4, and I end up with 216. Okay, This is when you could use the cube root button on your calculator. You could factor it out, move 3 out to find out what the cube root of 216 is. Because if we have r cubed, the only way to find out what 1r is to take the cube root of it. The radius is 6, okay? And we're talking inches, so the radius is 6 inches, okay? So watch that again, give it a try. You should be okay. I want you to pause the video right now for a quick second and try questions 1 and 2 right here. Okay? Make it nice and big and go ahead and pause it. Okay, the answer to number 1 is 2048 over 3. Got a little bit bigger. Pi, that's in terms of pi, which is about equal to, and it says the nearest tenth up here, 2,144.7 feet cubed. Okay, and on number 2, they're asking you to solve for the radius again, and the radius was 3 meters. So hopefully you did okay on those 2. Alrighty, let's go to example 3, which, you know, we worked with this kind of stuff before. This is just a composite solid. That means it's a solid made out of more than one shape. So just like a semicircle is half a circle, a hemisphere is half of a sphere, just like you guys know we live in the northern hemisphere. All right, so it says a hemisphere is 1/2 of a sphere. The top of the silo is a hemisphere with a radius of 12 feet. What is the volume of the silo? So a silo is just where they can store like wheat or grains and things on a farm. Here it is. You can see that it's made of a cylinder and of a hemisphere. So we basically just have to find the volume of each of these. Well, this is a cylinder, which is what we just did yesterday, okay, or Monday. So this is volume equals base times height. Volume equals pi r squared times height. Pi, the radius is 12, so 12 squared. The height is 40, okay? So this is equal to 5,760 pi, right? 12 squared is 144 times 40 gives you this. So this is the volume of the cylinder, and I'm just going to leave it like that in terms of pi because I do have to add these two together, and it's a lot easier to add together if they're in terms of pi. Well, this is a hemisphere. I know that a hemisphere is 1/2 of the volume of a full sphere, so I'm going to do 1/2 times 4/3 pi r cubed. Okay, so let's work that out. 1/2 times 4/3 is 2/3 pi r cubed, right? This is 1, this is 2, cross cancel, multiply your fractions, 2/3 pi r cubed, and then start substituting everything in. The radius is 12. This is 12 to the 3rd power, okay? So this is 2/3 times 12 to the 3rd power is 1,728. I'll put that over 1, 2, so you can keep seeing your fractions. And there's my pi symbol. Don't lose that, okay? And then we just kind of work this out. 2/3 times 1,728. This is equal to 1,152 pi. So that's the volume of the hemisphere. Here's the volume of the cylinder. We need to add these two things right here, okay? And when you add those, you get 6,912 pi. Don't forget to go up to the directions right here where it says round your answer to the nearest 1,000. That means they want no decimals. So 6,912 pi, that would be about 22,000 feet cubed when rounded. Okay, so there is your volume of the composite solid. All right, you guys, I know that was a lot. Let's look at these two. I want you to try on your own. I want you to pause it, but let's check. Woo, hang on 1 second. I almost dropped my iPad. Sorry, that was a little scary. All right, if you look at this composite solid, you could see if I kind of cover this up, there's a cylinder and there's a hemisphere and a hemisphere, but you know, if you have a hemisphere on this side and a hemisphere on that side, did you have a full one, okay? So it's a cylinder and a hemisphere. This one is a cylinder and a cone. So think back to the cone formula, which is 1/3 base times height. Okay, so hopefully you have paused that. I actually forgot to get the answers for you, so let me find those really quickly. All right, the answer to number 3 is, one second. This is 80/3 pi. That's what it looks like in terms of pi, okay? And that is about 83.8 inches cubed. Again, it's a cylinder and a sphere together. Number 4 is your cylinder and a cone together, and that was 96 pi, which is about 301.6 meters cubed, because the directions say the nearest tenth. All right, you guys, just lots and lots of formula work. Okay, now go give a few of these a try and come back to this video if you need a little bit of help, okay? See ya.